In this video, we're going to look at geometric mean, what the definition of geometric mean is, and how to use it in some triangles. So the actual definition of what a geometric mean is the geometric mean of two numbers, a and b, is the number x such that a over x equals x over b. And so your two numbers, so if you're given any two numbers, okay, you take the first number divided by x equals x divided by the second number, and then you can solve this. So what's going to end up happening is you would cross multiply. So you'd get a times b, and then equals x times x, so x squared. And so then you'd end up square rooting here, and you would get that the square root of a times b equals x. So really, if you're just given two numbers, the geometric mean is just going to be multiplying those two numbers together and doing the square root. So if I said the two numbers were 3 and 12, okay, the geometric mean would be the square root of 3 times 12. And so the 3 times 12 is 36, so the geometric mean would be 6. And that's because 3 divided by 6 equals 6 divided by 12. Both of those reduce to 1/2. So it's solving, or it's satisfying this proportion. So now how that plays out in triangles happens in a few different ways. So I'm going to focus specifically on one of the three cases that you could come up with in triangles. And so the altitude in a triangle, in a right triangle. So there has to be a right angle here. So this angle D is actually a right angle. So there has to be an altitude drawn to the hypotenuse. And an altitude just connects vertex to the opposite side at a right angle. So we see that altitude there. And let me just get this drawn on with a straight line. Okay, so this altitude needs to be drawn to the hypotenuse. And so the altitude is actually the geometric mean of the pieces of the hypotenuse that are created. So you can see that this point B splits the hypotenuse into two pieces. So we've got this AB over here that I just like to call a hypotenuse piece. And then we also have this other hypotenuse piece here, right? So we've got two different hypotenuse pieces happening here. And the altitude is the geometric mean of both of those. So the proportion that gets set up here is that we would have the hypotenuse piece, either one of them, it doesn't matter. So the hypotenuse piece divided by the altitude is going to equal the altitude divided by the other hypotenuse piece. So you have the altitude is the geometric mean. This is going to be both the same number. That's the altitude, okay, is the geometric mean of these two pieces that the hypotenuse has been split into. So one goes on top, one goes on bottom. So let's take a look at a couple examples of that. And I'm just going to take this part here, and I'm going to take it with us for the rest of the screens. So let's just move it down here. All right. So in this first triangle here, we see the hypotenuse AC, okay, across from that 90-degree angle. And then we see the altitude drawn here. And so if we're looking for the length of DC right here, so from here to here, that's one of the hypotenuse pieces. So we're going to set up this proportion using the hypotenuse pieces, okay? And so here's one of the hypotenuse pieces, 11 divided by the altitude, which is 33, is going to equal the altitude 33 divided by your other hypotenuse piece. So we've already used 11, so then x is going to go into this one. So now we'll be able to cross multiply. So we'll take x times 11, so that's 11x, and we'll take 33 times 33, which is 1,089, and then we'll solve this. So we'll divide both sides by 11, and then that gives us that x equals 99. So this piece right here is equal to 99. And the problem was asking us for the length of segment DC, which is our x value. So that is the answer to this problem. So DC equals 99. All right, second example. So again, we can see the hypotenuse here as segment AC. And then we can see the altitude here as BD. Now, this problem is asking for the length of the entire hypotenuse. So this one wants the length of AC, so that whole hypotenuse. But we're going to find the length of this little hypotenuse piece in our formula. So let's go ahead and do that. So our hypotenuse pieces are 7 and x, right? So one is going to go on top, one is going to go on bottom. Okay, so those two hypotenuse pieces, and then the altitude, and the altitude in this case is 14. So we have hypotenuse piece over altitude equals altitude over the other hypotenuse piece. So now we can cross multiply. So x times 7 is 7x. 14 times 14 is 196. Divide by 7, and we get x equals 28. So this piece right here is 28. Now, remember that that is the length of this segment from D to C, right? That's the hypotenuse piece. And this problem is asking us for the length of AC. And AC is this entire length. So AC is going to be equal to 7 plus 28. So both of those segments added together. So AC, the whole hypotenuse, is equal to 35. All right, let's do two more examples here. So in this one, we have, again, the hypotenuse here, AC, and then the altitude is BD. Now in this one, our missing piece is the altitude. Okay, so that's what we're solving for is BD. So when we set up our proportion here, our hypotenuse pieces are 14 and 15. So those are going to go along one diagonal. And then our altitude is x. So cross multiplying here, okay, we would get x squared is equal to 14 times 15, which is 210. And so then to solve for x here, we're going to square root both sides. And so the square root, if you do this as a decimal, the square root of 210 is equal to 14.49. So that altitude is about 14.49. Could leave it as square root of 210 if you wanted for an exact answer. Otherwise, 14.49 is the approximate answer. All right, then this final one kind of combines a couple ideas here. So we've got the hypotenuse. We've got the hypotenuse here. And we've got an altitude. So if we were to set up the proportion that we've been talking about in this video so far, we would have the hypotenuse pieces are y and x, and then our altitude is 4. So that creates a problem because we've got two variables here. So we aren't able to solve this proportion directly, so we must need to be able to find the value of one of those variables first. So if we look in this problem, we hopefully see that we have a right triangle over here that gives us 2 out of the 3 sides. So we would be able to use the Pythagorean theorem here to solve for x. So Pythagorean theorem, remember, is c squared equals a squared plus b squared. Your c value is across from the 90-degree angle, so in this case 5. So we have 5 squared equals 4 squared plus x squared. So we have 25 equals 16 plus x squared. Subtract 16 from both sides, and you get 9 equals x squared. So then we can square root that and find out that x is actually 3. So now we know that this value is 3, so we can plug it into our geometric mean proportion and solve. So now we can do 3 times y is 3y, and 4 times 4 is 16. So divide both sides by 3, and we end up with y equals 5.3 repeating. So we were able to solve for both x and y in that problem.